Alright, imagine you have a regular computer with tiny switches that can be either on or off, like a light switch. That's how computers work, using these on-off switches called bits. Now, think about a magical computer called a quantum computer. Instead of just having regular on-off switches, it has super-duper switches called qubits. These qubits are like the most amazing switches ever because they can be on, off, or even both at the same time, like magic. So, while a regular computer can only do one thing at a time, a quantum computer can do lots and lots of things all at once because of these special qubits. It's like having a super fast computer that can solve really tricky problems much faster. It's a bit like having a super-duper, super fast, and super magical computer that can do things no other computer can do. That's what a quantum computer is, all thanks to its super special qubits. Of course. Let's dive a bit deeper into how a quantum computer works. Imagine regular computers as very organized librarians who can only read one book at a time. These librarians represent the bits in a computer, which can be either a 0, closed book, or a 1, open book. Now, picture a quantum computer as a magical librarian who can do something incredible. Instead of just reading one book at a time, this librarian can read many books all at once, and even peek into the pages between 0 and 1. This is because a quantum computer uses qubits, which can be in a special state called superposition. It's like having a librarian who can read a whole library of books simultaneously. But that's not all. Quantum computers can also create a mysterious connection between qubits called entanglement. It's like having two magical librarians who can talk to each other, no matter how far apart they are. If one librarian finds something interesting in a book, the other librarian instantly knows about it, as if by magic. So, a quantum computer is like a super smart librarian who can read many books at the same time and share secret information with other librarians far away. His makes quantum computers incredibly powerful for solving complex problems much faster than regular computers. They use the magic of qubits and entanglement to do things that seem impossible with traditional computers. In the world of computing, a revolution is quietly brewing, one that promises to transform the way we solve problems, protect our data, and push the boundaries of what's possible. At the heart of this revolution lies the enigmatic quantum computer. What's quantum about it? Quantum computers are not your typical laptops or smartphones. Instead of using regular bits, which can be either 0 or 1, they employ something called qubits. Qubits are the magical building blocks of quantum computing because they can exist in multiple states simultaneously. It's as if they can be both 0 and 1, thanks to a concept called superposition. Imagine flipping a coin, but instead of seeing heads or tails, it's as if the coin is spinning so fast that it's in a blurry mix of both states at once. That's a bit like what a qubit does. This property allows quantum computers to tackle complex problems in a fraction of the time it would take classical computers. The astonishing power of superposition. Superposition is the secret sauce of quantum computers. It means they can consider many possible solutions to a problem simultaneously. It's like having an army of problem-solving ants that explore all paths at once, rather than just one at a time like classical computers. This makes quantum computers exceptionally fast for certain tasks, such as factoring large numbers or searching massive databases. Quantum entanglement, the magic connection. But wait, there's more. Qubits can also be entangled. Imagine two magic coins that are linked in such a way that no matter how far apart they are, when one becomes heads, the other instantly becomes tails. This is quantum entanglement, and it allows quantum computers to perform coordinated actions even across vast distances. It's like having a telepathic link between objects. Applications that'll blow your mind. The potential applications of quantum computers are mind-boggling. They could revolutionize fields like cryptography, making current encryption methods obsolete but also enabling unbreakable quantum encryption. They could supercharge drug discovery, simulate complex molecules and materials, optimize supply chains, and revolutionize artificial intelligence. Challenges ahead. As exciting as quantum computing is, there are hurdles to overcome. Quantum computers are incredibly sensitive to their environment, and keeping qubits stable is a monumental challenge. Researchers are developing quantum error correction codes to tackle these issues and make quantum computers more practical. The quantum cloud and the future. Companies like IBM and Google are racing to make quantum computing accessible through the cloud, allowing researchers, businesses, and curious minds to experiment with this technology. It's an exciting time, and as quantum computers continue to evolve, we're on the brink of an era where the impossible may become routine. In the world of computing, quantum is the future, and it promises to unlock new realms of knowledge, innovation, and discovery. Strap in, because we're about to embark on a journey into the quantum frontier.